review of the Edgenuity lesson, properties of logarithms. So really quickly, I'm just going to go over what the properties actually are. So the first one is the product property. And so if I have log of some base and then a value here that's being multiplied, we can actually split it up into two separate logs of what we're multiplying. So log base b of u times v is log base b of u plus log base b of v. So basically what happens is this, if we're spreading it out, the multiplication changes to addition. When you're dividing, it's very similar. You can spread it out into two separate logs, but the division goes with subtraction. So multiply goes with addition, division goes with subtraction. Last, the power property. If you have an exponent on your number here, what you can do is actually just take that exponent, bring it down to the front, and now it's just being multiplied by that log, which I've written out here. It would become n times log base b of u. So for example 1, they tell us that log base 5 of 3 is about 0.683, and that log base 5 of 7 is about 1.209. And so what we can do is we can use these properties up here to help us evaluate these. So if I have log base 5 of 3/7, that's not listed here. But we can rewrite this using and get it to look like a log base 5 of 3 and a log base 5 of 7. So what I mean by that is here we have a 3 and a 7, and if I were to split them up, now we just have to decide what operation goes in here. If you're splitting them up, division becomes subtraction. And so now we have these values that we can fill in. So log base 5 of 3 is 0.683. Log base 5 of 7 is 1.209. So if I subtract that, I'll get about negative 0.526. Okay, so think if you can figure out a way to write 21 using 3s and 7s, because that's what we have, log base 5 of 3 and log base 5 of 7. It's actually 3 times 7. So now that I have it written that way, I can use the product property to pull it apart. So I can write out two separate log base 5s, one with 3 and a log base 5 of 7. When you split them up like that, multiplication becomes addition. So we know that log base 5 of 3 is 0.683 about, and log base 5 of 7 is about 1.209. So if I add those together, I get 1.892. Okay, so now the last one. Is there a way that we can write 49 with 3 or 7? There's two ways you can do this one. Since we've already done a multiplication one, I'm going to rewrite 49 as 7 squared. So now what we can do is we can use the power property and bring this exponent down to the front of our log. So now it's just 2 times log base 5 of 7, which we know what that is. That's 1.209. So 2 times 1.209 gives us 2.418. Okay, so example 2 asks us to expand log base 2 of 7x cubed divided by y. When it asks you to expand, that means we want to stretch this out into the longest equation that we can. So we're going to use these properties here, because see how these are they're condensed, and splitting multiplication to addition and division to subtraction stretches it out. So that's what we're going to do. So first things first, we're going to take care of this big division bar because it works like a grouping symbol. So division turns to subtraction. So I'm going to split it up into two logs. So log base 2 of the top and log base 2 of the bottom. And as I said, division changes to subtraction when you're splitting them up. So now, if I look here, there's nothing else to do. Log base 2 of y. There's nothing being multiplied, divided, exponents. It's stuck. But here, there's a couple things I can do. This is 7x cubed. So that means it's 7 times x cubed. So that means I could split that up. I could go log base 2 of 7 and then log base 2 of x cubed. Multiplication becomes addition. And then minus log base 2 of y. There's one more thing that we can do. We have this x cubed, this exponent. So remember, the power property means that we can bring that down in the front. So we're going to have log base 2 of 7 plus 3 times log base 2 of x minus log base 2 of y. Okay, 2 more examples. So on this one, it asks us to condense. So right now, this is spread out as far as it can go. What they want us to do when it asks us to condense is we want to rewrite this with just one log. We're going to shove it all back together. So when you're doing this, the first thing you should do is notice if there's anything being multiplied in the front. So this 2 times log 2, the first thing I'm going to do is I'm going to put it back up as an exponent. So I'm going to write log 6 plus log of 2 squared, which we will evaluate here in a minute, minus log 3. From there, if you have any parentheses, you would do that next. But since we don't have any parentheses, we're just going to move from left to right. So first, hold on, before I'm not changing anything besides I'm just simplifying 2 squared to 4. Okay, so if I want to condense this into one log, if we have log 6 plus log 4, what did addition go with? It went with multiplication. So we're just going to multiply 6 times 4, which is 24. Okay, so now we're just down to 2 logs. So we need to put those together so there's just one. So if we're putting it together, it's kind of like the opposite. Subtraction went with division. So if I want to combine this, I'm going to change the subtraction to division. And 24 divided by 3 is 8. So that whole thing just becomes log 8. They talked about the change of base formula a little bit on the Edgenuity lesson. Just as a reminder, what we talked about is the log that's on your calculator, it's base 10. Remember when they don't write anything in there, it's assumed to be a 10? So on my calculator, there are some that are more advanced that can do this. I can't figure out log base 3 of 7 with this, just this log, because it's base 10 and I can't change the base to be a 3. But there is a formula that you can use it's called the change of base formula, to evaluate this on your calculator. So what you do is you just do log of this value, it goes on the top, divided by log of whatever the base is, the little number next to the log. So I would just go log 7 divided by log 3, and so it's about 1.771. So again, change of base formula. The numerator is this value, so log 5 divided by log of whatever your base is, 2. So on that one I got about 2.322. And the last one, again, this value's in the numerator. Whatever your base is goes in the denominator, the bottom. Log 14 divided by log 5, it's about 1.640 or 1.64.